All right, ladies and gentlemen, this is 3-4 functions. Our goal was to do what, Haley? So we talked about tables, we talked about graphs, we talked about equations. We have 5 very important vocab words: function, input, output, domain, and range. Functions as tables, graphs, and equations. We have some graphs in your notes. So if we go to our notes, actually I'm going to go to our last graph here that we created, right in here. We created a graph using y equals 3 minus x squared. We plotted our points using x and y as our table, which is the new way we're going to use tables right now. And then all of these lines here are proven to us that this graph is a function because of the vertical line test. Vertical line test, which is in your notes, states that any graph is a function if you draw a vertical line and it only intersects it in one particular location. Yes, no? Okay. The other way that we have a function is if every input has exactly how many outputs, you guys? 1. How many? 1. Every input has exactly 1 output. So looking at a graph like this, do we have a function? Yes. Yes. If you drew a vertical line anywhere on this graph, or if you looked at the table, you can see that every input has exactly 1 output. Vertical line works like so. Okay, any questions on that? Really, those are the 2 main points. When you have a function, you can use the vertical line test to prove it, or you just look at the input and the output tables if you have those created. We don't have a graph there. This is an example of something that's not a function, yes or no? Yes. It's not a function because of the vertical line test. As you can see, it's crossing our graph, which is the circle, more than once. And we're also seeing that the input of 1 has an output of 4.2, which was plotted right here. And the input of 1 also has an output of negative 2.1 approximately, which was plotted right there. Therefore, we have 2 ways to prove that we don't have a function. Yes, sir?
Isn't it 3.2?
I have over 1 down 2.1, I think. Oh, you mean on this top one?
Yeah.
Over 1, 1, 2, yep, 3.2. 3.2, not 4.2. Okay? And real world, anything that travels in time is going to be an example of a function or a graph that is a function. Then we can think about our circle graph, the one that was a circle that we drew a line through and intersected twice. That's actually a graph. It's a legitimate graph for something, but it's not a function, which is what we're working on. And the definition of a function, according to our notes, is what, Chris, Rosa? What's a function?
A rule that relates to one.
Good. So if you have something that's relating more than 2 quantities, you do not have yourself a function. So when I go back to this graph right here, we have 1, and as Aiden just told us, 3.2. We have 1 and negative 2.1. Here's 1 quantity, here's 2 quantity, here's the 3rd quantity, and we're only comparing something that relates to quantities. Questions?